transaction fee and this gas price thing. What are these? If we zoom in a lot more to these pieces here and we roll over transaction fee, we can see it says it's the amount paid to the block producer for processing the transaction. And then gas price is going to be the cost per unit of gas specified for the transaction in Ether or Gwei. The higher the gas price, the higher the chance of getting included in a block. I'm going to explain that in a little bit, but if we scroll down even more, let's zoom back out, and we click to show more, we can see even more details about this transaction. For now, we're just going to click to show less and just focus on the details that are here. So let's talk about just the concept of transaction fees and gas for a second, because they are important concepts for you to understand. Remember how I said that these blockchains are actually run by a group of different nodes? Well, the question is, what's their economic incentive to keep running these blockchains? Are they running them out of the goodness of their heart? Well, on a real network, these nodes actually get paid a little bit of Ether for processing transactions. Whenever you send a transaction, there is a node, sometimes referred to as a miner or a validator, depending on the network you're on, who gets paid a little bit of the native currency of the blockchain to process that transaction. For Ethereum, they obviously get paid in Ethereum. Or for Test Ethereum, they get paid in Test Ethereum, which again, the Test Ethereum is worth nothing, which is why I said they're running them out of the goodness of their heart. If you're sending a transaction on the Polygon network, they're going to get paid in Matic, the native token of Polygon. If you send a transaction on an L2 like Arbitrum or Optimism, you're going to get paid in ETH, which is the native token of those L2s. This payment is obviously to incentivize people to continue to run nodes. And they get paid more the more gas you use. So what is gas? Gas is a unit of computational measurement. The more complex your transaction is, the more gas you have to pay. For example, if we hit more details just really quickly, and I zoom in a little bit more, we can see this section here, gas limit and usage by transaction. This means that when we sent this transaction, we limited it to a maximum of 60,000 gas, but in total, we only used 21,000 gas. This 21,000 gas represents how complex this transaction was. It was 21,000 gas units worth of complexity. Now, for simple things like sending Ether, the units of gas are usually pretty small. For example, 21,000 units of gas is actually a really small amount of gas being sent. But maybe for more complex transactions like minting an NFT, depositing some funds into a DeFi protocol, or deploying a smart contract, those are typically going to be more expensive transactions because they're more complicated. They have to do more stuff. In the future, we'll introduce you to this concept of EVM codes or opcodes. And if you break down a transaction to the lowest level, this assembly opcode stuff, you can actually see exactly how much each opcode costs in terms of gas. Don't worry about this at all right now. Just know that these transactions are broken down into many, very, very small instructions, and each instruction has a specific amount of gas. More instructions usually means more gas. Like I said, we'll explain this much later in the course. Don't worry about this too much here, but just know that we use 21,000 gas. Now, if you take this gas used and multiply it by the gas price in ETH instead of Gwei, so we'll take 21,000 and multiply it by this gas price in ETH, not in Gwei, and hit enter, we'll see the total transaction fee of the transaction. And you can see that this number does indeed match the transaction fee. For you to understand how much ETH you're going to pay for your transaction, you multiply the gas price times the gas used. Transaction fee equals gas price times gas used. So this means that whoever sent us this 0.1 ETH also paid 0.0000525 blah, blah, blah ETH to a blockchain node to a validator on the Sepolia Ethereum testnet. Now, each blockchain has their own unique way of calculating how much transaction fee someone's actually going to pay. For most EVM chains, this is the simple algorithm. It's going to be gas used times gas price. After we understand how the blockchain works more in depth, I'll explain to you what the rest of these values stand for. For now, just know that anytime you make a transaction on chain, you have to pay the validators or the blockchain nodes a little bit of gas or a little bit of the native token of the blockchain, which in our case is ETH. So you have to pay a little bit of ETH to the blockchain nodes providing or sending the transaction. Sometimes I'll refer to this just as transaction gas. Let's look at an example of this ourselves. If we pull up our MetaMask, We go ahead and hit expand view. As we know, we have two different accounts in here. We have account 1 and account 2. Account 1 has 0.1 Sepolia ETH. Account 2 has 0 Sepolia ETH. If I send 0.05 from account 1 to account 2, how much do you think I'll have left in account 1? Let's go ahead and do this. And this is going to be the first transaction that you send on the blockchain, which is incredibly exciting as well. Let's go ahead and hit this send button in our MetaMask. We'll hit send. We'll hit transfer between my accounts. We'll select account 2 and we'll say 0.05 Sepolia ETH. So we started with 0.1 Sepolia ETH and we're going to send 0.05 to account 2. We'll scroll down. We'll hit next. We can see some information here about what's actually going on. We can see some gas information, which MetaMask automatically prompted for us. And it even gives us the total amount that we're going to be paying in ETH. It's adding this 0.05 ETH to the estimated amount of gas that we actually have to spend. So that at the bottom, it says the amount plus the gas fee is the two of those combined, the value that we're sending plus the gas fee. And additionally, in MetaMask, if you select this here, you can get some more information about editing our gas fees. The amount of gas that you choose to spend can be different depending on how many people are making transactions on the blockchain. The more people are sending transactions at the same time, the more expensive gas costs are going to be. So if a lot of other people are also sending transactions right now, the gas price is going to be higher. If a lot of people are sending transactions, that means there's not going to be enough space for everyone's transaction to get through. So in order to throttle that, they increase the gas price. That's a bit of an oversimplification of what's happening, but if you take that understanding, that'll pretty much work. If you want to specify exactly how much gas you want to spend, you can click the Advanced tab. If you select 0 gas, there's a high likelihood that your transaction will never go through. So we're just going to go with the default, which is usually a good idea. So let's go ahead and confirm. We now see a send transaction in our queue in the activity tab of our MetaMask, which shows us that we have a transaction currently sending. And if we click on it and click View on Block Explorer, it'll actually open us up on Etherscan, and we'll see, well, mine was a little bit quick, but normally we'll see a little indexing tab, and we won't see this having gone through. We'll see it as like indexing or sending or something like that. But after a little bit, it'll actually finish sending. You might have to wait a minute or so for this to actually finish going through, but it looks like mine was really quick. And same as our last transaction, this has a lot of the same information. And if we scroll down, we'll see that, of course, we sent a different amount of ETH, 0.05, and we have a different transaction fee. Now, if we pull up our MetaMask, what do you think that we're going to see? We're going to go ahead and click Expand View again. And we see account 1 says 0.05, and account 2 also says 0.05. That's kind of odd. I thought we spent some gas. Well, if we click on the big accounts button, we can see exactly how much ETH is in each account. We can see we have 0.0499 in account 1 and 0.05 in account 2. And we can see in our activity history, our account 1 recently sent 0.05 ETH, and account 2 recently received 0.05 Sepolia ETH. Now, here's the best part of all this. Even if you don't want to become a developer, you just learned the basics of sending a transaction and interacting with sites using your MetaMask. Congratulations.
Now here's something that's incredibly exciting. With just this little bit of information, you now know how to interact with blockchains and interact with the Ethereum protocol. So if you don't want to learn how to code anything, you can go and you can start interacting with Ethereum and interacting with protocols with just this much information. However, I know most of you guys are here to learn how to code. So let's look under the hood of Ethereum and what is actually going on with these transactions and with these gas and with these blockchains and what's really going on. Let's learn all the fundamentals of a blockchain. Now, if you want to just go ahead and jump into the coding, go ahead and grab a timestamp from the description. However, learning exactly how the blockchain works is going to make you an incredibly powerful developer. So let's take a look at that first.